With the primary fuselage secured, the space shuttle is ready for its next major structural integration. Internal structures provide the strength hidden beneath the outer skin. Piece by piece, the spacecraft begins to emerge. Every surface is prepared for the next engineering stage. Temporary fasteners hold every component exactly where it belongs.
Surface perfection is essential for aerospace performance.
Cleanliness is critical before structural joining begins. Thousands of precisely manufactured parts come together in sequence. The payload bay forms the shuttle's versatile working space in orbit. Every material is positioned exactly where production will begin. Critical metals are protected from contamination from the very beginning.
The orbiter's structure begins to take its recognizable shape.
Heavy lifting equipment now takes over the delivery process. Even the smallest movement is controlled with absolute precision. Even suspended in the air, every movement follows a carefully engineered plan. Controlled lifting protects both the structure and its precision-machined interfaces.
Digital inventory tracks every material from arrival onward.
Every movement is carefully controlled to protect these specialized components.
Measured performance must match the predictions made during design.
Electrical distribution prepares every onboard system for testing. Ground support equipment becomes the shuttle's temporary lifeline during testing. Every structural addition is verified before the shuttle grows any further. Inspection confirms every dimension before production continues. Every structural connection is verified before production continues. Advanced inspection confirms every protective tile meets exact aerospace standards. Every seal is verified to protect the crew in the harsh environment of space. The aft structure must withstand enormous forces during launch. Hundreds of interconnected systems must work together as one. Planning begins long before the first part is manufactured. Every electrical pathway is verified before advanced systems are installed. Internal logistics keep production moving without interruption. Verification ensures every shipment meets aerospace specifications. Every permanent joint is verified before the next assembly begins. Every tile is individually manufactured and installed in its designated position. Heavy structures move with millimeter-level control. Thousands of precision fasteners unite the wing with the fuselage. Automated inspection captures details beyond the limits of human vision. Every thermal protection tile is installed with individual precision.
Every dimension is compared against the original engineering design.
Every thermal protection tile begins with an accurately controlled bonding process. Automation ensures consistent geometry across every panel. Every mounting fastener is tightened to precisely engineered specifications. Thousands of precision fasteners permanently unite the shuttle's forward structure. Hydraulic power brings the shuttle's mechanical systems to life. Large structural panels begin their journey toward final assembly. Controlled forming creates the curves needed for flight.
Even microscopic leaks must be found long before launch.
Internal reinforcement provides the strength required for launch and re-entry.
The wing leading edges receive the shuttle's most heat-resistant protection. The raw material now reaches the first manufacturing department.
The manufacturing process is finally ready to begin.
The crew compartment is prepared for one of the shuttle's most critical structural joins. The shuttle's onboard computers begin taking their place. Every connector is designed to perform reliably under extreme conditions. Large structures move slowly because accuracy cannot be rushed.
Temporary positioning ensures every structural joint remains perfectly aligned.
Preparation protects materials before fabrication starts.
Every electronic system is verified before the shuttle can leave the factory. The crew's view of space depends on windows engineered for extraordinary strength.
Thousands of automated checks confirm the computers are ready for flight.
Every control surface responds with measured precision before flight. Precise alignment ensures reliable operation both on Earth and in orbit. Every moving assembly must perform reliably through repeated operation.
The payload bay doors must operate flawlessly throughout every mission.
Now, precision engineering begins shaping the future of the space shuttle.
The shuttle's three main engines now form a unified propulsion system.
Perfect alignment ensures the engine will transfer enormous launch forces safely into the orbiter. The propulsion system is the heart of the shuttle, demanding extraordinary precision during installation.
Each engine is handled as one of the most valuable components of the spacecraft.
The next layer will protect the shuttle from the extreme heat of atmospheric re-entry. The shuttle now enters the final stages of exterior precision finishing. Beyond these doors, raw materials begin their transformation. Thousands of perfectly aligned holes prepare the structure for assembly. Temporary positioning protects the accuracy of every structural connection. Precision alignment begins long before permanent assembly.
Perfect alignment must be achieved before permanent joining can begin. The next stage joins the spacecraft's largest structural components. Every tool is selected automatically to achieve aerospace accuracy. Permanent fastening transforms separate assemblies into one spacecraft.
Every millimeter is measured before the next component is installed. Advanced inspection confirms every surface matches its engineered profile. Precision alignment ensures protection where re-entry heating is most intense. Specialized structures prepare the orbiter for its orbital maneuvering systems. Orbital maneuvering systems allow the shuttle to change its path once in space.
The aft section now receives the structures that will stabilize the orbiter throughout flight. With the core structure complete, the shuttle is ready for the systems that will guide it through space.
Pressure testing confirms the integrity of critical sealed compartments.
With the primary structure complete, the shuttle is ready to receive the complex systems that will bring it to life.
With propulsion installed, the shuttle is ready to prove every system before leaving the factory. Alignment at this stage determines aerodynamic stability during flight. Every major assembly is inspected once more before installation. Composite materials demand carefully controlled environmental conditions.
Alignment is the foundation of structural integrity. With its essential systems in place, the shuttle is ready to receive the propulsion hardware that will carry it beyond Earth's atmosphere. Permanent fastening transforms precise alignment into lasting structural strength. With the wings taking shape, the space shuttle is ready for full structural integration. The entire integration process is repeated with the same uncompromising precision.
Every major assembly is inspected one final time before integration. Alignment determines the structural integrity of the entire spacecraft.
Heavy structures move only under complete control.
Temporary locking ensures every load path is perfectly positioned.
Preparation is essential before the shuttle's thermal shield can be installed. Thousands of electrical connections create the shuttle's nervous system. Temporary fasteners hold the entire structure together for permanent joining. Even the smallest gaps are engineered for safe performance during re-entry.
Hydraulic systems provide the force required to move critical flight surfaces. Life support systems are carefully integrated to protect future crews.
These pipelines will deliver supercooled propellants during launch. Before systems arrive, their pathways must already be perfectly prepared.
The final inspection creates a complete digital record of the finished spacecraft.
After thousands of inspections, the shuttle earns its factory certification. Controlled loading verifies the strength hidden within the shuttle's structure.
Before flight, every onboard system must prove it can operate exactly as designed. With its systems verified, the shuttle is ready to receive the protective shield that will survive the heat of re-entry.
Thousands of coordinated operations support a single spacecraft.